Let's go ahead and get started. Hello, everyone, and welcome to our panel discussion here. My name is Frank Trevino, and I'll be the moderator. Our discussion, of course, is innovation trends in Europe, and it focuses on aerospace. However, we're going to do a little deeper dive. I believe that we are at this inflection point, this critical point where we're talking not just about aerospace, we're talking about defense, and we're talking about space all coming together. In the past, these were always individual conversations. Now, we look at it collectively, especially with everything that's going on in the world today. And I think, as we look at this, it's understanding some of the pieces as it relates to bringing these three sectors together. Dual use technology. We talk about innovation around the dual use itself. We talk about the geopolitics and understanding some of those pieces. But we also have to understand the transatlantic collaboration that takes place around innovation, that takes place around security, and also these commercial opportunities between Texas and Europe. Today, I want to make sure that we as a panel, that we're not just discussing some of these pieces here, but it's really kind of understanding what's driving it. And so I think that's going to be the important takeaway as we go through. And after, we will have a short Q&A question, if there's any questions to ask. Real quick, I'd like to do a Q&A session. I'm sorry, not a Q&A session. I'd like to do an introduction session here real quick with all of us. Myself, my name is Frank Trevino. I'm the managing partner with Illumulus. We are a digital transformation group, and we're based out of Austin, Texas here. I have 25 plus years in the space industry, and I'm also serve as an advisor to the United Nations as well as State Department. And so I'd like to ask the other panelists to jump in and give a 1 or 2 minute introduction. So, Sam.
Hello, I'm Sam Peterson, and I've been in the space industry about 30 years as well. And I got my start in the Army, so I was a soldier that was a space operator, and then I moved into kind of the institutional space. I worked at the European Space Agency for about a decade, and I was also the interagency manager for missions that we did with NASA and with the German Space Agency, the Italian Space Agency, the UK Space Agency, and so on. Then I moved out into industry and eventually moved back to the US as well, and worked in industry for a number of years. I worked for companies like SAIC, the Swedish Space Corporation, Telespazio, Firefly Aerospace here locally. And now I spend most of my time doing consulting and teaching. I teach at Embry-Riddle Aeronautical University, and I volunteer locally as the president of our local chapter for the Space Force Association, trying to communicate what Space Force is about, what the space industry is about, and how people can get involved in the space industry, because the space industry is a big growing sector, and we need every type of expertise, not just engineers.
Good morning. My name is Mark Lebovitz. I founded L2 Aviation about 30 years ago, and our whole focus and our belief at founding was to make things simple in our industry. Our customers really needed solutions that here before that wasn't available, so we spent a lot of our energy coming up ways of making complex situations simple, often from a end-to-end perspective. So on the panel, I'm going to be more of the last end of a lot of the implications and the implementations of a lot of the technology. But I went to UT Austin right here, electrical engineering student, and it is great to be back on campus and just kind of seeing how much it's grown around here. A lot of what we do is on the aircraft integration, so we'll install new systems, whether it be satellite, and it's from the big aircraft that fly all over the world all the way down to drones.
Par, you want to give a brief introduction, please?
Sure, I'll try to keep it short, but we'll see where we end up. Anyway, Per Johansson is my name. I'm based just south of the Arctic Circle in Sweden. And I'm working across a region where scale, distance, and climate shape everything we do. And it also includes how we approach space up here. We're, of course, not quite the size of Texas, but we have many of the same challenges when it comes actually to scale, both scale when it comes to geography and also how we scale things. And as some of you in the audience might know, I've been working with UT Austin since 2012. And today there is an established collaboration between my university, the University of Technology, and UT, where we cover both research and incubation. So this is actually, for me, a long-standing transatlantic partnership, which I'm very happy to continue building on. In my work, I'm a typical senior advisor on industrial transformation and innovation system, where I'm working supporting both industry and public sector actors. And it tends to be often in the intersection of policy investment and large-scale industrial development. In my region, northernmost part of Sweden, we host something called S-Range Space Center, which has been around since the early 60s. And it's one of the very few sites in Europe where we are now developing orbital land launch capacity. And in a European context, it plays a role comparable actually to Starbase in Texas. Of course, it's another, we have another very different climatic and regulatory and geopolitical conditions up here. So I will try to on my part of this, be the guy on the stage that talks about the perspective from Europe and especially from Sweden, of course.
Thank you, Parv. I'd like to start off with the question for Sam. Sam, what are the most important shifts happening right now in aerospace, defense, and space in Texas, and why do they matter?
I think, there's a lot going on in space in Texas. Historically, Houston, of course, with the NASA Center there was a big focus of space in Texas. In fact, famously, I hear our governor say that the first words spoken from the moon was Houston, right?
Exactly.
and that's always been kind of an anchor for space in our state. But there's so much more going on, and a lot of it is driven by the Texas Space Commission and the economic development in the state, which is investing in the space activities around the state. One of the most visible things going on is on our southern border. Down in Brownsville, we have SpaceX who's set up down there, and that's where they build and launch Starship. So for those of you who might not be aware of the scale of what Starship is and what they're doing down there, you're talking about a rocket that's the size of a skyscraper, and they're mass producing them like Henry Ford mass produced cars. And it's pretty amazing to see that. They have them lined up and they can launch them, at a pretty regular cadence. They're still working out, the early stages of getting it to production capacity and launching on a regular basis. But once they do, this is going to, be the next fundamental leap in the space industry as far as being able to take a lot of mass to orbit and to do it very cheap. And cost drivers are what have transformed our industry in recent years. So the last 10 years or so, I would say the cost to launch has come down. And I think the best description of this, when I was living in Europe, I tried to do a startup briefly, and we had a startup evening, and we invited a speaker from SES, which is a Luxembourg-based company, and he was and we all did pitches all night, and he said, we recently went from Aerospace to SpaceX, and this was 10 years ago, 12 years ago now. He said, we recently transitioned from Aerospace to SpaceX, and the price to launch one of our satellites has gone down $40 million. So every time we launch a satellite, our company is now saving enough money that I could fund every one of your business ideas that were pitched here tonight. And I think that really, to me, sums up the difference in price. And launch has come down another order of magnitude, and it's about to come down again with Starship coming online. What this does is it creates new viable business opportunities. So while communications was viable back, at the end of the 20th century, now you have Earth observation businesses, you have, lunar transportation businesses, you have new business ideas popping up, and you can get your idea to orbit and test it out and prove that your business concept can work a lot cheaper. The barriers to entry have gone down, and that's enabling. Right now, Texas might be the first place that you're able to bring mass back down. They're talking about doing that out in West Texas. So Midland's looking at, the Midland Spaceport is looking at being able to bring mass down. Right now, U.S. companies that want to manufacture in space and bring things down do it in Australia. So these are things that are transforming our state, here in Austin locally, out in Houston, down south, out west. There's a lot of things going on in space here in Texas.
And just to give some people perspective of what launch cost looks like, we always base it per kilogram. Before reusability, we were averaging around, I would say, 15 to 20,000 per kilogram for launch. After reusability, we're looking at around 1,500, and they're hoping to get that down to $25 per kilogram eventually. So just to kind of paint the picture of all the things that are going on with that area. Mark, I'd love to get your thoughts on some of these same pieces here of any big shifts that you're seeing on your end within Texas.
Yeah, Sam, you made a good point. There's so much satellites going up. There's microsats. There's small. There's large ones, and there's so much capability right now. What we're seeing in our industry is that there's talk of things like hyper connectivity and hybrid communications. And really, what those are saying is there's opportunities now to take, rather than the pillars and the just individual hardware solutions there used to be for so many years. Now, because of all this capacity and capability with communications and bandwidth going to space and back, now people are able to come up with applications that are more software oriented, and you're able to come up with creative, innovative solutions that just weren't available before. And when you talk about hyperconnectivity, really that's a way of saying always on. And the old way of aviation was when you wanted to get a position report sent to air traffic control, you did it in a way where it was like every 14 minutes. Well, now you're able to do it continuously. You're always on because of the capability. Then you have hybrid communications. There's capability now where before you had one means of communicating to an aircraft to and from the ground. Now you have multiple hybrid ways of doing it. So you're able to communicate with a backup system or a primary system. Now they're starting to combine those two. And so it's the least cost solution for the airline. So when you're flying, there's an expensive way to do it that may be more safe, but they're finding communications now where you could go the low-cost passenger services in the back could be used now for safety services. But since you have two of those potentially on an aircraft, that becomes more reliable than maybe one system in the flight deck. And there's all these redundant systems that are coming in. They're using satellites now for space-based VHF. That's the one acronym I'll use. It's the same frequency you use for FM radios for your car. Now they're putting those satellites in space. It's 400 miles up, so it becomes a 400-mile tall tower. That allows people all over the world to be able to communicate with the exact same radios that have been in the aircraft for, 60, 70 years. And so that technology becoming available, people are becoming creative. And from a passenger perspective, that means you're going to get there safer, more on time.
Oh, very interesting. Par, I'd like to ask the same question to you, but on the European side. Do you see similar shifts taking place on the European side or something different?
A little bit of both, actually. I think the biggest shift happening right now in Europe is actually the policy shift, and it's happening, of course, due to the new situation we have on the scale of where our neighbors in Europe are actively trying to take control over each other. So the big policy shift happening in Europe right now affecting space is that we're moving from space as a pure science area into space as a key infrastructure. And we can actually see that on the financial scale quite easily. As you might know, in Europe, we work with 7-year funding programs. We are on the one now that ends during next year. And in that program, we have approximately a $16 billion EU space program out of a total of $100 billion for something called Horizon Europe, one of the global's largest research program, publicly funded. In the next budget cycle coming up for 28 to 2035, they will double the Horizon program from 100 billions to 200 billions. And then on top of that, we are creating a new European competitiveness fund at approximately $500 billion. And from those 500 billion, approximately 140 billion going into defense, security, and space. So definitely, space is taking a lot of positive money inflow happening right now. And for Europe, this is something completely new. So definitely the shift from space being seen as a science area to as an infrastructure. And of course, on top of that, investments and a lot of new scale-ups and startups being both created, but also at the same time, we actually tend to, of course, buy a lot of technology from you guys in the US.
You know, you mentioned policy, and that's something that we'll talk about a little bit later here to come back to that. But I'd like to jump into another section here of innovation. And Mark, I want to start the question off with you. Where are we seeing the most interesting innovation, especially around dual use, and what's driving that?
Well, for us, there's a lot of technology innovation happening around the whole drones. I'm sure you're reading it in the papers. There's going to be millions of drones flying around, moving cargo. They're unmanned in most cases, but the innovation's happening on the fact that you're going to have to think about how do we do the air traffic control for all these drones. And there's a lot of innovation going around what used to be home use technologies like Bluetooth for your headset or Wi-Fi for your home internet. Now those things are being applied to things like drones where they could communicate amongst themselves as they're flying around in the structure of the air traffic control systems. And the innovation is being forced because you're going to have to make sure everybody around the world is going to be able to communicate. And what I find very interesting is what used to be, your cell phone now becomes air traffic control in a way because all these drones are going to be communicating where anybody could look at where this drone is, and the requirements and the regulations are driving some of the innovation in the sense that, they're going to have to report where they're at. It's really like a digital license plate for each drone. It's called a remote ID. So they're having to present their ID, where they're at, altitude, and all those, the position they're really located, but also the position of the operator that's flying the actual drone. And we're seeing a lot of opportunities even as we work more on the larger aircraft, but some of the detect and avoid technologies that people are being forced to create where the drones are talking to themselves, that's starting now to potentially apply more into the larger aircraft. We've had some bad incidents, as you know, in Washington, D.C., where a commuter jet hit a helicopter. I mean, technically it was the other way around. There's a lot of technologies that are out there, but what we're finding is the technology's there, but it's not being used consistently. And I think as time goes on, you're going to see a lot of these technologies because there's going to be millions of drones. It's going to be tested, perfected, changed, evolved, and it's going to be a more safe world.
With technology, we always see technology first, right? And then policy, governance tends to come years later almost. How big of a problem can that be moving forward with the number of drones that are going out there? Does policy need to catch up? Does it need to move faster in order for us to be successful, I guess, of maintaining this?
It's interesting because Europe has taken a different approach from the FAA on how to handle that potential issue. Europe is more of a risk-based scenario, whereas the FAA has been more prescriptive. And they both have pros and cons. I find that, like in the United States, if you have a drone that's more than 250 grams, that's like a little bit more than half a pound, you have to have the remote ID that I was talking about earlier. You have to transmit where you're at. Whereas in Europe, it's more of if you're going to fly near a city and you're going to do something that could potentially have problems within affecting somebody else, then you have to start reporting. But what I find interesting is in the United States, they're kind of flipping this whole right of way that's always been. If you have the larger, faster, more maneuverable aircraft, you have to avoid the lighter, slower, not able to maneuver very quick. But they're kind of flipping that here in the United States, and what they're saying is, if you're going to not transmit your location. Is anybody here a pilot or fly with somebody that has a little private airplane? So one thing you may want to be thinking about if this new rule goes through is that if you're not transmitting your location, which is not currently a mandate, you have to avoid the drone. You have to avoid all these little things that are going to be flying around. And so the FAA is basically forcing it without a mandate to say, hey, look, you really should be transmitting your locations. And if you are, then it's up to the drone to avoid you.
So I want to direct the same question to you, Sam. It's really looking again, where are we seeing the most interesting innovation, especially dual use, from your perspective on the defense side or space side?
I mean, there's so many things going on, between launch and orbit, but I think one of the sectors that I would concentrate on the innovations going on is in the Earth observation sector. So, we started Earth observation with satellites that would literally drop, canisters of film back in the 1960s and 1970s, and have evolved to, first government satellites that were doing Earth observation, and now commercial satellites. And commercial satellites, you have Planet, is one of the companies. I mean, there's a lot of companies in Earth observation, but one of the leaders is Planet, and they have very small satellites that they put up, and they have a lot of them. They have one of the largest fleets of satellites doing Earth observation right now, and their whole motive is their whole company's vision is, we want to be able to photograph everything on the Earth at least once per day. And in some cases, video and multispectral, they're getting more and more capabilities as their fleet refreshes, because they've been around a few years, and that creates a massive amount of data. And they've had to move kind of their compute to the edge some years back, because they have to say, hey, what's valuable to send down and what's not, because we're recording so much data, we can't bring this all down, and even if we bring it all down, our customers can't sift through all this. So they've got to kind of think of it in a product approach of what's valuable. And they had a kind of a game changer a few years ago, where they had been collecting all this data, and of course China and trade with China, being how it's been over the years and how it's evolved. There used to be a report that would go out every month, which was the industrial capacity of Guangzhou, and at one point, the Chinese government decided that it was embarrassing because the industrial capacity of Guangzhou had actually decreased. So they stopped sending this report out. Just, hey, we're not sending it out anymore. And of course, the financial sector around the world thought that the report was valuable. And the Planet said, well, we've been recording all this stuff for years. Let's go back and take a look. So they looked at activity in the port and the amount of emissions that were coming out of, how many cars are parked in parking lots. And they were able to model, based on the previous reports, what the drivers were, and a month later, they put the report out and sold it to financial institutions around the world, based on data that they've been collecting for years. And now the innovation is now coming down to the ground, where what is the downstream is where the value are. So these companies can record things like crops and climate factors, and really change how we do agriculture, how we do energy and transportation. Can all be, you have a new real estate developer that wants to build like a new subdivision, and you can do a whole traffic study based on satellite data now. And that's a game changer. That wasn't available even 10 years ago.
Yeah, I was having a conversation with a colleague of mine, and we were talking about AI coming into play now too, because of the amount of data that's being captured. You have latency challenges, so you can't bring all your data down. But with AI, it's going to help categorize it to a certain degree with that, and then hopefully that'll help deliver certain information, from a different perspective.
Absolutely.
I wanted to ask Par a very similar question on the innovation side, but Par, I'd like to understand more on the space side of things as well, from a dual-use technology. What do you see going on the European side?
Three main things happening. Of course, some of them you heard before, that there is an increasing overlap between the civil programs and the defense budgets. That's new. EU was funded out of the Second World War, so EU hasn't been working that much with the defense funding before. All of a sudden, the civil programs and defense budgets are looking at the same time. The other thing happening is of course that there is growing national investments happening alongside the EU level funding. So there's a lot of money being put into dual use, both from EU and from the national level funding. But the main thing happening in all of Europe is that we can take Sweden as an example. The Swedish Defense Material Administration, they are rapidly changing how they buy new technology and capabilities, and especially within the space sector. So shortening the innovation timeline is key. Typically, before, it took them 5 years to order something new. And now they are looking at how can we order new technology from the space sector within 6 months. So the timeline is definitely shortening, and dual use is the key here. So dual use is not just shaping technology; it's also shaping how and where how fast billions in public funding can be utilized actually. So it's really increasing tempo. That's what's happening, and dual use is the key to make sure that it happens.
You mentioned that they are putting more money into the programs like this. Is this something that has been consistent, or is this something that we're starting to see more injection of funds into programs altogether?
There is a big shift happening right now in Europe, especially when it comes to funding, because in Europe we have always been very how to put it correct, a very partnership-oriented approach, where we have friends wherever we can find them in the world. All of a sudden, the policy shift is that it's about Europe's competitiveness. We see China on one side as a competitor, and we see also US on the other side as a competitor also. So this is changing how we actually prefer where to put money. And space is in the middle of where a lot of money is going right now.
So I want to kind of stay on that subject you mentioned with Texas and Europe, and this one for Sam. Where is Europe leading right now, and where is it catching up, from your perspective?
That's a good question. So I think Europe is. Let's start with kind of where they're catching up. So Europe has been lagging behind in launch, especially. I would say that's one of the areas that they've really tried to catch up, because they have Arianespace kind of leading their launch sector, but their launch facility is in South America. There's no real launch capacity from the continent of Europe. There's suborbital launch in Sweden, in Norway, in Scotland, and some other places, but actual orbital launch is something that they're trying to develop on the continent. And that brings us to kind of the idea of sovereign capabilities. They want to have the ability to launch their own spacecraft. And a few years ago, it was unthought of that they would use U.S. launch providers for European missions, but now European Space Agency missions routinely go up on SpaceX launch vehicles, because that's where, that's who has the ride available at the time that they need to go. And that was a fundamental shift, because now they're paying SpaceX to do that, whereas in the past they had to pay a European company to do launch, and that was a shift in the last few years. Areas where they're leading, I think that the Copernicus program, I used to be in charge of operations for the ground segment for Copernicus for a number of years, and I think that what they're doing with the Copernicus program is showing what you can do with a government Earth observation program, making data available to to companies to create new products out of it, also to characterize the environment, to monitor, Sentinel-5P, for example, is part of the Copernicus program, and they have a sensor on board Sentinel-5P, and now P meant precursor. Sentinel-5 just recently went up, but there they can track sulfur dioxide, and in fact, it's the only instrument on orbit that can. So when you see these maps that show like the hey, this volcano erupted, and here you can see where all the sulfur dioxide went, or you can see the pollution over cities measured by the sulfur dioxide content. Those always come from that trombone instrument, which is really interesting. I'm like, oh, I know where that came from. Every time I see one of those maps, it's very specific, and I think Europe's leading in some of those kind of big tentpole climate-related things.
Mark, any perspective on your relationships with European companies or organizations?
Yeah, I'll start with where Europe is leading. They have a need in Europe where there's a lot of congestion for all the existing ground-based systems. When you want to communicate to an aircraft, there's air traffic control that goes back and forth. There's data about the aircraft you want to send back to your operations hub. There's where you're heading. They call it 4D, which is your position plus time. So they could have trajectory. You could plan exactly where the aircraft needs to be well in advance, so you don't have to fly and then do maybe a holding pattern near an airport, waste fuel, waste time. It's very plan oriented. And what they have realized is that there's not enough capacity, because in Europe, the airports are so close, there's so many aircraft, that they had to go to a new satellite-based solution. And to Sam's point, there's so much capacity, so much being launched now, the abilities are there. And where they're ahead is being able to drive that technology, whereas in the United States, we're still using the older ground-based solutions. Well, then that kind of goes back to what I was talking about before, about that 400-mile tower in the sky for the FM radio type communications, the VHF systems, where we're going to look at it here. How could we now use that technology in the United States so that the operators, when they're flying the aircraft, they don't have to add a SATCOM system or satellite communication. They could use their existing radios exactly the way they are, but now go through space. So in a sense, it becomes a satellite communication. It's just on a very different frequency band. But I also will add that the Europeans are forward-looking. They do know what the requirements are because they have so many needs. But I find that Texas and the United States in general, we're very good about scaling and implementing things, coming up with solutions. It's like some of the programs I was talking about, our company is certifying these for the very first time in the United States with US-based operators that happen to be flying into Europe. So even though maybe it's European-driven technology, we're sometimes the early adopters here, which I find to be interesting. So you have the lab-based readiness level, technical readiness level, but somebody has to make it flight worthy. And sometimes we in Texas just get it done.
If I could add on to
Please go ahead, yeah.
what you said about communications is really, in space vehicles is also commercially much more advanced in Europe, I would say. In fact, for NASA, their commercial partners are a Norwegian company and a Swedish company. So and I used to work at the Swedish company, and when I was at ESA, I worked with both of the companies, which also do services for the European Space Agency. But they have ground station assets that are in the Arctic Circle in the island of Svalbard for the Norwegian company, or northern Sweden for the Swedish company. They have ground stations down in Antarctica. They have them in Australia, and they built these ground networks around the world. And now they're the two leading companies in that space, and a lot of U.S. companies are playing catch up. Or once you get enough satellites, it also makes sense to build your own ground infrastructure because you own the whole end-to-end infrastructure. But for companies that are using that service, or space agencies using that service, I would say Europe is further ahead in developing that kind of infrastructure.
Par, anything else you want to add to that?
No, I think you're nailing it. I mean, very short. US, especially Texas, of course, market-driven, fast scaling, where we in Europe tend to be policy-driven, system-oriented, and infrastructure heavy. So I think we in Europe, we're building the more coordinated and policy-driven ecosystem, but it needs to accelerate both speed and scale, and you get it done. I really agree. You make it. Without you, we wouldn't be where we are.
So staying on the subject of Europe, I want to go back, and this is a question for Sam, for the team as a whole. But Sam, there's constant mention of the term space sovereignty in Europe. What is space sovereignty, and what does this mean in practice?
So space sovereignty is really, wanting to have that capability, at a national, or in Europe's case, it could be at the European Union level, which is a little bit different than the national level there. And that really started, I would say, with GPS. So the U.S. led the way with GPS, and then at some point, Europe decided, hey, we should have our own capability to have GPS. So they created the Galileo system. The Russians also have GLONASS. The Chinese have Baidu. So there's different navigation solutions that are out there, and commercially, you can use really any of these. If you have like a shipping fleet around the world, you can commercially use any of these navigation solutions if you have a receiver that can decode the signals. But the important part for them was having their own navigation capabilities, so they didn't have to rely on a foreign power, be it the United States or Russia, because they were friendly with both at the time, to do their navigation. That since moved into the creation of the European Space Program, which is separate from ESA, which has Galileo. They now have Copernicus and that's funded through the EU to do Earth observation satellites, like I said. And now they're talking about doing something called Iris Squared, where they want to kind of create what Elon Musk has done with Starlink as a sovereign service in Europe, so they can offer communications from low Earth orbit to European companies and European industry and European nations, as a service. But that's still kind of nebulous. They're in the early planning stages of Iris Squared, I would say, and the industry is trying to wrap their collective heads around how to implement that.
Hey, Sam, just to add to that, what we're noticing is that all the GPS technology, the global navigation solutions that you were talking about, there's a lot of different options, but they're almost all susceptible of being jammed or spoofed. And I'm sure you see a lot of these situations. And so back to that hybrid communications I started with, an application is that now you're starting to use things like Iridium, which is basically you could use it for Iridium phone call. That could also provide a lot of data to the flight deck to be able to say, look, you're being spoofed, you're being jammed, and it can provide another level of information that wasn't available before. And it's all being combined into one easy solution for people.
We talked about with sovereignty and where it's going. In the early days, space station, ISS shared across many countries. Do you see sovereignty being something that individual countries are going to start developing their own space solutions? Or do you still see shared resources across countries?
I think there'll be some shared, and there'll be some where they want to have their own solutions. You talk about the ISS, but even earlier back, you had the Apollo-Soyuz mission that happened in the middle of the Cold War. Could you imagine doing something like Apollo-Soyuz with China right now? I mean, we seem to have taken a step back diplomatically. It used to be that above the Kármán line, we were kind of all friendly, even if down on the ground we didn't get along. But now, the conflict might eventually move up into space, maybe not physically, but jamming GPS signals or jamming communication signals. There's been anti-satellite weapons that have been tested by at least 4 different countries. That causes a potential tragedy for, causing space debris to become an even bigger problem than it is already with a lot of the space junk that's up there, which is it could be a whole topic for a whole panel. Yeah. But
our next panel discussion.
But yeah, so there's a lot of interesting things around space sovereignty, I guess.
Along the same lines, Par, I kind of want to talk to you about very similar. You mentioned before about European strategic autonomy along these same lines. Could you give some examples of this around launch capacity or other reduced external dependencies?
Sure, we can. Some of the things, outside of the space areas, of course, that the autonomy in Europe right now is focused a lot on the critical raw materials. We have a very low autonomy on we buy quite a lot of those from the rest of the world, of course. So that's one thing that really are stressing a lot of politicians in Europe right now, and we also see a lot of investments happening in making sure that we can actually open more mines, for instance, to get that type of key assets out of the ground. And in comparison to that, what's happening also at the same time when it comes related to the space sovereignty, we of course focus on, as we said before, independent access to space, the launch capability, but also the control over the data and also the infrastructure. As an example, S-range is, some of you have been there, where it's in the middle of nowhere, especially in the middle of nowhere. So it's quite hard to actually reach it physically, S-range, but it will be such a critical infrastructure requiring protection. So that's a lot of investments happening also in not just in just controlling the data, but also controlling the infrastructure itself. And at the end, also trying to reduce the dependency on external providers. But we're not there yet. I saw some lines last week where Firefly, a company from your part of the world, will deliver launch capabilities at S-range during 26. So the autonomy is something that really are stressing a lot of European leaders right now. So space is one part, and the other side is critical raw materials.
I kind of want to jump into policy now a little bit, similar to what you're talking about there of how quickly someone or the government can move. But I want to start off with Mark. You know, we often talk about regulation slowing things down, becoming a barrier, which is very common. But have you seen where regulation has actually accelerated innovation?
There's quite a few. In the case of Europe, the defined, we were talking before about trajectory-based operations, you really need to be able to have regulations that can then drive the innovation, because you have to set the playing field so that all the different people around the world know exactly what, if they build it, the airlines and the operators could manufacture it, they could buy it, and they could just do the whole ecosystem. So sometimes as engineers in the industry, we enjoy good regulations because it gives a very specific mandate for what is required, when it needs to be done, and in most cases it's all around improving safety. Now, not all regulations are good. You know, we see those as well. But there's also the same thing happening in the drone world. It's a wild, wild west with a lot of the things that are happening, and regulations are settling people down where they can actually make now decisions on what they could do and when they could do it.
Sam, I don't know if you have anything else to add on your perspective on regulation side. I know you and I were talking earlier. Regulation is always, it's difficult, the governance piece.
I mean, it can slow things down for sure, but I think that where regulation can help things is when there are clear standards that are set up, so you can have interoperability. If the industry is moving in lockstep and doing things the same way, you know, and sometimes those standards come from industry themselves, and then they're recognized by a government body, and it becomes, you know, maybe codified as a regulation or not, you know. But I mean, thinking, you know, like USB, you can plug a USB into just about anything now and it just works because that standard is there, you know. And electrical standards in most countries make it so that it's easy to make things that work on the electrical grid because you can just plug it in and it works. And yeah, if you travel, you need to have an adapter for the power in that country, you know. But the fact remains that having these standards makes interoperability easier, which means that it opens up a lot of opportunities and capabilities.
Kind of goes back a little bit to what we were talking about with the sovereignty, right? As we look at different countries producing their own efforts, they could have their own standards as well, and that'll be interesting to see how things kind of move forward in the future around that. So,
absolutely.
The last section here I want to talk is just more on being practical. And again, back to you, Sam, here. You know, for companies looking to work across Texas and Europe, how can European countries engage with Texas?
I think in the space sector, and getting back to, you know, I mentioned about space sovereignty from Europe's perspective more earlier, but here in the U.S. we have a lot of kind of buy U.S. policies, and we have ITAR restrictions. You know, getting back to policy that can slow down, you know, cross-border trade, let's say. And so I think one thing for European companies that want to operate here, it's good to set up a U.S. entity, you know, and to have, you know, take a look at, you know, Texas might be a great place, but in the space sector there are, you know, a few hubs, and they have different strengths. Same way on the other side of the Atlantic, there are different hubs in Europe that might make sense for a U.S. company that wants to go there. So find out what's being done in Texas and what the ecosystem looks like for, you know, your particular business. You know, the upstream, your suppliers, the downstream, your customers, are they all located here in Texas? Are they located in Colorado? Are they located in California? You know, there's a few hubs that are interesting to look at. And when a European company is thinking about making market entry in the U.S., explore that strategically for your company before you make, you know, your first moves. Because once you make your first moves, you might anchor yourself somewhere, and it might not be, you know, for the best for your company's strategy if you end up in Virginia, for example, or Minnesota. You know, maybe your customers aren't all there, for example. I see a lot of European companies that go and they just go out to an executive search agency and say, hey, we'll get a U.S. CEO, and they'll set up our U.S. company, and they'll drive it. They'll know what's going on. A lot of times what you get is you get like a VP from Lockheed Martin who now gets to be the CEO of a European company's entity in the U.S. That's who gets recruited. And he's like, you know what, my family's from upstate New York, so that's where I think you should move your company. And then they set up shop in upstate New York, and it's like, well, after 3 years of this guy being in charge, much has happened for my company in the U.S. I thought the ecosystem was really big in the U.S. If he had moved the company to Houston, maybe it would have taken off, right? And I see the same kind of mistake made a lot of times where they put the person on the ground before the strategy, and then economic development. You can also, play that game like building a stadium, right, or hosting the Olympics. Same kind of thing for setting up your company. If you're a European company coming to the U.S., make that decision a little bit later, and then go to Texas and say, hey, I'm thinking about bringing 1,000 jobs to Texas to build my rocket, right? So, but I was in Florida last week talking to them, and they got a lot of great ideas too, and their economic development team wants me to come to Florida. So tell me why Texas is better. That's what I would do if I were a European company coming to Texas. Even if I know I want to be in Texas, make sure to take a look at the other states. Make sure that you're making a good strategic decision and you're getting the opportunities when you first establish yourself, so that you have a good runway.
Par, I want to throw the same question to you, but kind of reverse it a little bit. How can Texas companies engage in Europe?
Yeah, I think it's a quite perfect opportunity to do that. And I mean, where you in Europe, we can offer system integration, public programs, long-term demand from today. So there's definitely need here, and we need more companies that come and help us with those. But I think the companies coming from US or Texas entering into the European market, they have to understand the regulatory differences really early, because there are quite a large difference between them. The key is to build local partnerships, and I agree. There is a lot of hubs being available where you can build those local partnerships. The same type of analysis the other way around, of course, but also be aware of the dual use implications. This is a very sensitive situation right now in Europe as we are building up our own capacity. So I think that might be really valuable to also look into the dual use implications with your technology when you bring it to Europe. But I think the opportunity for American companies lies in combining Europe's systems approach with the US execution capacity. That will be very relevant for Europe to have companies that can help us with that entering our market.
So it sounds like it's doing everyone doing their homework then. Mark, can I add?
Yeah, for large companies like Sam was talking about, they want to have a presence, they want to have a large facility, but we're also working with smaller companies that aren't ready to relocate or have an office in the United States or Texas. So we're partnering with them. They have technology. We have the ability to kind of hit the made in America. There's a lot of requirements for the defense that there's a certain amount of content that has to be made in the United States. So companies like L2 could manufacture it here in the United States. We could help market it. We could sell it and be that front for some of the smaller companies that have great products but are not really sure how much they want to grow with the footprint here.
Kind of on the same lines, I mean, from an operational standpoint, how should companies think more strategically then along those lines?
Yeah, for us, I think there's a lot of technology that I would say we've used the word dual use quite a few times today. I think there's a lot of opportunities for what was a commercial application in Europe because of some necessity that was created that could be reapplied here, whether it be on an aircraft or ground station. The whole ecosystem from end to end, there's a lot of changes happening quickly. And, one example is there's a head-up display that goes inside of an oxygen mask. Well, that was at the Consumer Electronics Show, was a head-up display that you could see information that now can be presented to a flight crew. Well, it was put inside of an oxygen mask. So in the case there was cockpit smoke you can't see, now you could don this commercial electronic. Of course, it was ruggedized and made into an aircraft part. But there's a lot of things like that somebody has in one industry that could be applied over now to aviation.
Oh, that's pretty interesting, actually. With time being what it is, we'd like to actually open the floor up to questions. If anybody has any questions they'd love to ask. Come on, one question. There we go.
Question on going back to some of the standards that you talked about, either communication, interoperability, especially as we're converging a lot of the communication stuff between ground and satellite and everything. Having been in that situation working with the ITU and the other kind of international standards, one of the challenges I see is how do we get companies that can participate in that process and dedicate people into that process? Because it's a tough process to go through, especially in international space. And a lot of people go around it and go around it, but what I'm seeing is an aging out in some cases of those standards people and not much filling back in on the younger, because it takes a long time to get into that process. How do you see, do you see an answer to that, or where do you see opportunities to improve that situation?
Yeah, I think it is a challenge. When I think of like the communication standards, I guess one of the biggest drivers is what they call the CCSDS. So there's an acronym for you, the Consultative Committee on Space Data Standards. And this has a lot of agency and industry support from Europe, from the US, internationally, trying to drive these standards. But a lot of the, having used these standards, there's some room for interpretation. And the way that one agency does it or one company does it might be a little bit different from a way that another company does it. So that doesn't really necessarily lead to interoperability. But what does is as people are using, kind of being driven by these standards, just the mass adoption of one implementation of it eventually leads to other companies doing it that way. So it's not perfect, and it doesn't necessarily have a standard that people just read and, okay, I build it this way and it works. It doesn't necessarily work there, but we eventually get there. And overall, I think it's working pretty well, being not so heavy-handed that they're telling everybody how to do things, but everybody kind of, the standards, kind of happen in committee in different places and then get codified, and then people implement that, they try it out, and then the things that work get adopted by industry.
I think just to add to that too, from my experience in the technology side, best practices over time, right? I mean, it's going to take a while for something to go through, just as you mentioned, but these best practices start to develop out of that, and then sometimes it just starts to kind of take hold a little bit, where then it does become something that's used by many. The adoption is the hardest part.
I think, for people my age, a good example is, back when video cassettes were a thing, you had Betamax and VHS, and Betamax was very much a superior technology at the time, but Sony tried to own that and tried to make everybody go through Sony to do it, whereas VHS was an open standard, and a lot of companies just adopted VHS, and pretty soon Betamax was just not used anymore. And I think the more that individual companies try to impose their own way of doing things, because they want to try to make money off from everybody doing things their way and connecting to their system, I think there's going to be more examples of that, kind of trying to force your way of doing it not being a good business practice. Try to find ways that work with others, and then the pool is bigger, right?
It sounds like it's whoever has the most money, right? To drive their product.
Yeah, Apple likes driving their own standards, right?
Exactly. Mark, I don't know if you wanted to add anything on that.
I agree with all that. I will say I've been watching a trend in our industry where the large manufacturers like Boeing and Airbus are starting to really drive the regulations and the mandates and the data that's coming out, as opposed to when I first started, it was the airlines, it was the manufacturers of the equipment itself, and maybe it goes back to who has the money. It's like they have the ability to staff, and then they're selling aircraft.
We have another question over here.
Okay, hi. Thank you so much. It's been really interesting. One of the things that I've been sort of reading lately, and would like your comment, is the, kind of like in satellite, I think the whole industry is around the payload, right? It's really what's actually up there that's driving the economy. With this potential advent of spatial communications, orbital data centers, and the upcoming largest IPO in history with SpaceX, how do you see all of that kind of transforming, you know, the industry and literally the economy, right?
So yeah, I mean, I think that as more capital comes into the space sector, you know, you're going to have more things happening. Like I said earlier about the price of launch coming down, that additional influx coming into SpaceX through that IPO means that Starship now starts having regular launches, and it brings the launch cost down, like you said, maybe not to $25, but maybe it brings it down to $250. Right. You know, and keep in mind that there is a difference between launch cost and launch price. So the prices probably will come down slowly, but SpaceX's marginal costs will go down much faster because they're the ones that own Starship. You know, but they'll be competitive and they'll need to fill up all the capacity in that, which means that will drive down, you know, launch costs for their customers as well over time, which means that other launch providers will have to be competitive with the prices that Starship can offer taking stuff to orbit. And that'll open up new opportunities. Every time the launch costs go down, that means that the barriers to entry for interesting things that could be done in space go down. And you know, we mentioned a lot of the new things that have, you know, become a reality in the last 10 years with launch costs going down. An order of magnitude drop again with Starship and with the IPO from SpaceX will mean that things that we're not even talking about are going to happen. So people are talking about space data centers right now. People have been talking about that for maybe 5 or 10 years, but in the last year, it's become really a big conversation piece and really, you know, big money players getting in the game with space data centers, making it look like it might happen sometime soon. What's the next technology that maybe we're not even talking about yet? You know, or something like, you know, space-based solar power that's been talked about for decades, but nobody's really implemented it. You know, are we going to be able to actually generate power up in orbit and beam that power down to Earth at some point? Or maybe we power spacecraft that don't have to have their own power because we're beaming power to each of the spacecraft. You know, there's new innovations that'll happen. And trying to guess at what those next innovations will be, you know, is just wait and see. You know, wait and see what the innovative young minds that are graduating from university today come up with as their barriers to entry go down.
Any other questions? Oh, yes. Go ahead, sir.
So one part of our organization does a lot of manufacturing, automotive, defense, across the board with transportation. So we are interested in metal, things that are made of metal. And one of the things in the last couple of years that we've seen is automotive have been sharing very specific areas of design across the board, from Korea to various other places. It's the same little part. It's not the big parts. It's the little parts that create the bottleneck. Are you aware of anything that's happening within basically in the aerospace? We're aware of some of the things in defense, but it's more of a sensitive matter. But on aerospace, things that would be more in the public domain, going from Europe, Asia, and the United States, where they are starting to look at the standardization of these extremely critical pieces, but they're usually small, and they're high in number.
What do you think, Mark?
Well, in our world, you know, we've had to solve that problem a little bit differently, which is we've had such a challenge with metal. We're an avionics company, but the ability to get what you're referring to has been a dramatic challenge. And so rather than going outside of the United States, you know, we're looking to close, you know, this week or next week in acquisitions for a metal manufacturing company so we could control more of the vertical integration. It's a speed to market issue. A lot of what we make is our design, but there's also build to print, as we call it, or other people. But we're not in the commodity as much as what I think you're referring to. We're more of a high mix, low volume type thing where they're very specific products, almost like customized for applications to install certain types of different avionics on the aircraft. But it is definitely a challenge in the marketplace.
Last question, I believe.
I don't have a question, but thank you so much. I've learned a lot. And I would like to just add one point. You've mentioned drones. And this is something that is fascinating me. That's why we've decided together with my husband to organize a summit 28th of October. And we would love to have you there as a speakers also, if you are interested. Let's talk. And thanks to the University of Texas, because we finally have the agreement. It will be happening definitely in October 28th. Thank you so much. Thank you.
Well, thank you. Thank you very much. Real quick, lightning round with the panelists here. One thing to watch for in the next 12 to 24 months. Anyone can go.
I think with the announcement that NASA just made in their ambitious plans for the moon, I mean, in the plan that Jared Isaacman just released, he said that he wants to see 10 moon landings next year, which is phenomenal. I mean that's more moon landings than the entire Apollo program had, right? I don't think those are all manned. I think a lot of those are uncrewed. In fact, the ones next year will almost definitely be uncrewed. But still, I mean the Eclipse program has had like four landings to date, and only one of them kind of completely successful. So having 10 landings next year and more the following year, leading up to building a lunar base, I think that's an interesting vertical to look at how the lunar economy is developing.
I totally agree with that. I think with Artemis launching tomorrow, it's again, things are moving forward, progressing. I've been in chats with companies planning moon cities, and now with the announcement, that's really helping drive the momentum around that. So, Mark?
Not near as sexy, but the HF radios, little acronym, high frequency. Back in the day, that was high frequency, but that was 100 years ago. In the next 12 to 24 months, we're going to be involved and be able to take those old systems off the aircraft and replace them with some of the things that Sam and Frank and other people have been putting up into space to allow us to certify the ability to start saying you don't need 100-year-old technology anymore on aircraft.
Well, like you said, that was 100 years ago, and you look at the frequencies that have come out after it, and they just keep adding a new adjective. So it went from very high frequency, ultra high frequency, super high frequency, extremely high frequency.
Very, very, they always add that, very now.
Then they started using letters like K.
Par, real quick, anything you want to add?
No, I'm already into popping some Artemis popcorn for tomorrow. But I think definitely it will be interesting to see how people outside our nerdy world of space and will look into the lunar landings coming up. So that will be really interesting.
Well, thank you, everyone. We appreciate you spending some time with us today, and I want to thank the panelists as well. Thank you for your time also. So have a great event.
Thank you, Frank.